We are Entras. Together, we build software for controlling flexible assets for the industry.
We strongly believe that the future will be flexible. Any industry, big or small, any building, any home, will make use and make profit out of flexibility.
That future starts now. In this podcast series, Flexing the Future, we share our insights on flexibility.
Welcome to our podcast, Flexing the Future. Today, we will be talking about energy management systems. And we have a special guest today. That's Beazar from Enprove. And my colleague Stijn from Entras will also join the discussion. Anne, can you introduce yourself and Enprove?
Yes, thank you for the invitation. I'm happy to be here. Enprove is a company that started as a consultancy company where we help industrial companies to save energy, save CO2. And during the years, it has become more and more an IT company where we use data and data insights to kind of be the support for the consultant, for the energy specialist, to make sure that the industrial companies can move forward faster and better on the energy team. All right.
Today we will talk about energy management systems, and one of the main questions is, what is it? What is an energy management system? So maybe the first question, what is it for you?
Yes, for us it has always been starting from data, trying to find insights in the data in order that the result is an action to be taken. And this action usually should be an improvement, saving of money, saving of costs, and so on. So in the beginning, it was how we perceived it. It was like one direction of data. So you want to measure what is going on, you capture it, you try to see patterns in it, you try to find the insights, and based on this you can do reporting, you can find the actions that you need to do. And I would say there is what I would call the reporting goal for companies where they don't need a lot of data, they just need the main points once a month or once a year.
The right data.
Yes, for reporting purposes. But if you switch to the operational side and where you really want to have a tool that is assisting you in your daily operations, that is telling you, be careful, you're having an energy loss, you're losing money on this machine, then you really need more high-frequently a data source, and you also would have to have some alarms and some intelligence. So you need more data points, and you need to measure also more things to get more insights. So this is, in my view, this one-directional approach where you capture data, where you see, is everything going okay? If it's not, where you have this alert. But I think more recently it has become more and more important to also have this way back and being able to control also what Entras is doing.
Yeah, indeed.
Yeah, where you can, based on the data that you capture, you can also send back. Because 10 years ago, the main way of saving costs on the energy bill was by just saving money, saving kilowatt hours, consuming less energy. Yeah. Well, today it's still saving energy, but there is this large cost component, and the supply of energy is more variable. So there is this controlling component that has become a lot more important than in the past.
That is indeed where the if I can call it, energy management system of Entras positions itself. So we focus only on optimization of assets on what I call the energy markets. So today you pay for every kilowatt hour you use, but because of the renewables, there is a whole, let's say, a volatility in the market, and prices can be very high. Let's say that the average price would be somewhere between 40 and 70 euros, but peaks of plus 500 euros or more, or peaks on the negative side to minus 500 euros per megawatt hour. These kind of volatile prices are now much more present than even 3 years ago. Let alone 5 years ago. And so for Entras, we made a choice to offer a solution to control this kind of control within the possibility of the process, to control the position of the company, to optimize the total cost of energy. And so within the, let me call it EMS ecosystem, there are lots of EMSs, and they all have a focus. They're all good in something, but that something is very often different from all the others.
Yes, indeed.
Yeah, and I guess that's a major problem if you are an industry and you want to buy an energy management system. First, you need to understand what is this, what does it deliver, and then you have to make the choices for your own company. And that's a difficult question, right?
Yeah. Yes, I agree, because there is already some new, in my eyes, some new terminology where we talk about an EMOS, where the O is for the optimization part.
The first time I hear it.
Yeah, so there's the EMS, which is just capturing the data, as I explained before, and then there's the EMOS, where you also get this feedback from the system, and where you start. So what you're doing is more the optimization and bi-directional information, but it's I think what I see in the market today and in the whole ecosystem today is you have the companies that work on reporting that are more in the CSRD reporting or other SBTI, this type of things where you have this low frequency. Even you could do it in Excel, let's say, and have your monthly reports. And there are already tools there in the market that are called EMS. Then you have the tools where you can capture data and find the insights on what machines are not working well. What should we do to reduce the consumption, to reduce CO2? This is an EMS. And then you have the tools where you look more to when should we consume, when should we buffer, when is the energy the cheapest, what your specialty is. So there you're in the EMOS, let's call it that way. So it's a very different goal, a very different type of application. But in my eyes, there is just one certainty that the companies will need detailed data from their energy to be able to have a reasonable energy and a predictable energy costs. Because as you said, the more and more companies are obliged to take on variable pricing contracts, and they will be punished if their profile cannot match in a certain way the availability of energy on the market, and if their profile cannot be buffered, so they will have a lot more costs than a company who can.
Yeah. So an industry should basically first decide what characteristics do they need. Do they need reporting? Have they assets that they can control? Do they want them to be controlled? From the needs, they can then go a step further. But what is really remarkable in the sector of, let me call it a sector of energy management systems, that is that you see almost only very small companies. And there is no, I've never seen it on the internet, maybe I see it tomorrow, but there is no one big company with an energy management system that is considered to be standard and that all the big companies use it. No, it's like a lot of innovative people are trying to find out what does the industry need, and they start with their own companies, and that is what you see today. You've like maybe in Belgium and the countries around it, you have hundreds of companies actually that are into some aspect of energy management systems.
Yeah, and it I think if I speak from our experience in industry, the companies that have like the broadest approach and like the most a very future-proof company. How do they tackle the energy and data aspect? They are not starting from this, I have to report every month, because it's not giving you more insights than just that. So they start measuring more data, and they usually have this goal of one, saving costs, because it also will give them a budget, and saving costs can come from using less kilowatt hours, and two, by knowing when to use, like doing the time shifting and the buffering. And then another goal they usually have is saving CO2, which is by implementing roadmaps and programs to electrify, do other things. And then another element can also be using data to negotiate the best possible contract with their procurement. Yeah, indeed. So if these elements are all there in a system, I think you have the basis there for like a future-proof approach, where you maybe today will focus on cost savings and CO2, and where when your contract changes, you might more focus on flexibility. And I think these elements should be there, and also there should be a very future-proof data layer where you're ready for AI applications, where you can have metadata, where you can have ontology, so you enable reasoning in a later stage. So, but if you want this, as you said, there is not one one-stop shop where you can find it. So what we try to do is building an ecosystem with the different companies that have different specialities, where you do the flex part, you're very good at it, but you link to a data framework that is very future-proof, and then there's another party who can do the costs contracting. There's another party maybe who's doing the scope 3 carbon footprinting. Maybe the company already has a reporting software where we can link to. So you kind of make this almost like a tailor-made system, which is not tailor-made at all, but it has the right components, and it has the parties involved who are really into the subject, because it's a complicated it's becoming more and more a very complicated matter. Yeah, and
maybe one day it will consolidate, but that's not the path towards consolidation is not clear at the moment.
So. No, and I'm a strong believer of bringing together the competences and building this common, like today, building API connections between tools. It's more common practice than it was 10 years ago. So there are really good ways of managing such a collaboration model between companies.
Indeed. It reminds me of other open source applications and stuff, but it's a sector in movement, huh? And that brings me to another question we wanted to discuss today. That is, of course, there is a big evolution of artificial intelligence, and I would like to better understand what artificial intelligence applications can we expect in the field of energy management systems. But maybe I ask the question first to Stijn. Hello, Stijn.
Hello. Well, I can say how we use and tend to use it at Entras. So at first we use AI purely for our software development, which is already like a huge time saver because it assists us in the non-creative, let's put it that way, part of our job, like reading in data and writing out data is not the most fun thing to do. Okay. So that's already one thing that we can easily outsource, and we do actively now in our team. But we're planning and we're doing tests also, like when we where we want to create like a full-blown application just as a proof of concept, as a minimal viable product to show to our customers and say, okay, is this what you want? And to have like have the software delivery part very much speed up. In fact,
all right.
So that's one thing. But of course, speaking about our algorithms, then we will also look at how AI can improve that. There are patterns that we probably won't see ourselves. So there we can ask AI, okay, can you give us some more clues and try to find in all this data, the market data, the historical data of a plant, of a customer, do you see trends that are unusual, and can it tell us something about something more than we could otherwise not found ourselves?
So that's discovering trends. And do you think it can also help predicting?
Yeah, I'm pretty sure. Based on historical, AI can better look at huge data sets and try to predict. But of course, with AI, the key there is context. So if you can give it the right context, it can do a lot. If you give it crap context, it won't be. So if you take out of the equation, for example, weather conditions, probably it won't do an as good job as you would take in the weather conditions, seasonality and so on.
And you could use it to improve your weather predictions.
Yeah. So it's a matter of giving the right context, and context can be market data, can be weather conditions, can be past process data, and so on. So that's the key, I think. Yeah,
for an energy management system, I think it should be probably possible to also predict the energy consumption of companies.
Yeah, sure.
Within the data set that exists, they could maybe artificial intelligence could help to extend, but even then, new knowledge might change it. What do you think? This is quite, let's say, logical. You can do better forecasts, but what would be the next trend for artificial intelligence?
Good question.
If you can guess. But the dream is for at Entras we make models of industrial processes. The dream is that we have in no time, based on the portfolio of digital twins and whatever that we have in no time the model for an industry that we did not model before.
Yeah, that's a good thing. So we could use the EMS data, in-out data, and give it to AI and say, okay, construct a model of this plant, for example, like a kind of digital twin thing that we can use for simulation and for operational purposes.
that would really move it forward.
I think I agree. Like you have the let's call it the delivery side. So when is there energy in the market, on the market, and how expensive is it, and when is it available, in what extent? So their AI will play a role in the prediction, as you mentioned. And if you look at the company side, you have the ways of handling this in a flexible way, being we turn off machines, we turn on machines, we put energy in batteries, we put energy in heat, and when to do it. You also, so there as well, there is some opportunity for AI. And one of the topics there is a big opportunity is in everything that is maintenance related. So if you know this is how my machine usually behaves, and then you see a behavior that is giving you different results, you can even go so far that you have a diagnosis, that you not only say, oh, this machine is consuming 10% more as we would expect, but then you could add, it's probably because this filter is fault or something. So that there is this application there. There is also the application of if you have the concept of metadata adding to your data, not only saying this is energy, I'm measuring this energy, but you also know it belongs to this machine and it has this unit, and you should normalize it first. But you can, like if we look at a typical industrial context, you could have 5 plants and they all have, let's say, an energy consumption from a compressor, and you can call this is an energy consumption for a compressor, and maybe you have some flows related to it. But if you use AI tools like ontologies, you can easily bring these different data contexts, which could be very different in different plants. You can bring them together and create additional insights that can help you either for the flexibility and for the steering, that can help you for the savings. So I think AI will be able to play a very important role in making everything a lot easier in the data interpretation, in the reasoning on the data. Yeah. So there is also some work being done at European level of creating this, let's say, common vocabulary to label data and to make the reasoning more easy. So I think many systems will evolve in that direction.
That's what Eunice now say. That for me, that's a very big question. If you go to different industries, then first, they do not measure the same stuff.
No.
Then you talked about normalization. You never know what a unit is if you see a number. Then the label is in some incomprehensible abbreviation. Even maybe sometimes it's not an abbreviation, just a combination of letters and numbers, and always different.
Yeah.
And then the usual way an engineer will tackle. Let's say there's a problem, he wants to diagnose it. Then he knows all these things for his company and knows the data structures. Then he goes to maybe he takes a PNID, a technical diagram of the equipment, and then he gets a lot of maybe alarms or measurement values. For instance, the example that you gave of a filter. So he can then make an interpretation of some parameters and it can suppose maybe there's something with the filter, but there are many other things that can be a problem with the motor or maybe with the measurement or with the control system. So I always wonder how can this be done that if you feed everything into a computer system without the normalization, without giving a meaning, without analyzing the connections between all the parameters, how can it how can that be done that then any system based on artificial intelligence pulls a useful conclusion from it?
Yeah.
Because I see so many hurdles.
Yeah.
I think it's not easy.
No, and like today, it's if there is not, or if the work of creating like a central data lake where there is some level of a uniform standard, if that's not the case, it's in many cases a hell of a job to link to different environments, different SCADAs, different operation systems. You need production data. Like if you look at EMS, it's also more than just link your main meters to the system. It's also about what do your machines consume, how much will we produce, what impact will that have on the production. So it's true that in reality today, it's like a mess in a lot of companies.
Yeah.
But still, I think there also AI has a role to play in the way of data, of understanding what are you measuring, and of already still be able to interpret and assume, this is also a compressor, and this is probably also the consumption. Although it's not called consumption, but it's called cons, whatever. So I think
then you're lucky.
It will,
then you're
it will,
lucky
and,
if it's
yeah,
called cons.
but or it can recognize the patterns, and it has like a similar behavior like as another compressor, for instance. So it will help there. What I see, I think today in industry is sometimes they look at it and they're like, oh, this is so complicated and this is so much work, and just leave me alone. It's not for now, it's for later. Although the financial benefits you have from doing something with the data can be very large, and so it's a missed opportunity in many cases. So our advice would always be like, start with something small and start measuring and start gaining insights, and then little by little you build a system, but you have to think carefully before you start if your system is future-proof.
Yeah.
You don't start. Yeah, you should start in an Excel, of course, but if you're like leveling up and like you're taking small steps towards like a future system, you have to start this process with a future-proof partner.
Yeah, but AI will, at least for now, but it will never be effortless.
No, and I think we should treat it that way as well. It's especially if you're trying to make something from a mess, AI can help, but you have to treat AI then also as your assistant. You're still in control, so it's assisting you, and it can suggest you and come over this hurdle of mapping the data, basically. And it will become smarter and smarter as long as you keep feeding it with relevant data. But at least for now, treat it as an assistant, and just that. Not the master, the single version of the truth or something.
No, yeah.
I agree with you on starting with a small project, but isn't there also a problem of awareness? So people tend to think in their little team, and there is so much to gain overall as you can see
exactly.
the company as a holistic machine rather than isolated machines.
Very good point. And especially now, as I said before, it was for companies, it was a matter of saving on kilowatt hours, while today it's like a theme where sustainability department is involved, procurement department is involved, the CFO should be there, the CEO is involved, the operations, maintenance. So it has become this multidisciplinary theme that's on the agenda in different forms of different people. And it has become not everybody is aware of what it can bring to them. Like the benefits are not clear, and it's like with everything, if the more effort you put in it, because I agree it is a lot of effort, the greater the financial benefits are, and this is not always something that they realize very well. So it is good for the sustainability, it is good for the costs, it is good for operations. So, but they're not at the same maturity in all companies. So there is some work to do in spreading the word, let's say.
Yeah, but let's say for the general competitivity of the industry, then let's talk in terms of Belgium. We need to get that moving.
Yeah,
I think that's would become a major issue if we do not follow the flow of the applications of artificial intelligence, but mainly get processes automized, get more insights out of it without hundreds of people needing to study it in automatic ways. Yeah.
You cannot manage it in an Excel anymore. That time is past. It's impossible to do it. You need like the intelligence in the algorithms that you are building, for instance. You cannot do it in like an Excel. You need some specialized tools. So that is really and the problem is the financial risk is getting so much bigger. Like if you would say 10 years ago we used 10% of energy more, okay, my bill will probably be like about 10% more expensive. Today, there is the government who announces higher capacity tariffs. It can have, for certain companies, it can have an impact of doubling their costs. So it is the stake there. There's more at risk. There is a very high financial risk today that wasn't there in the past. So the need of putting the effort and taking more control over it will be essential for companies to be in control of their costs.
Yeah, and indeed, if it's a complex industry, they need an overview or a system that takes any factor into account to react on maybe just this capacity tariff, because it has so many consequences in other processes in the company.
Yeah.
Yeah, and then a question that jumps to my mind now, if we interconnect everything, and companies today, they do a lot in the cloud. So I think cybersecurity must be a major issue. And how do you see that?
I am more like I'm a fan of doing certain things locally. Implementing certain things locally, not only for cybersecurity, but also for the risk. You have no internet, you have no connection. If your systems depend on it and they're high, let's say not necessarily highly critical, but maybe in terms of costs, like missing a moment can turn out to be very expensive. So I still believe there should be some on-premise local controlling. And on the other hand, just software security, data security is something that is also very important. And if you're talking to, if you're working for larger companies, industrial companies, it's a crucial must-have that you have a very good security system built in the software.
Yeah.
Yeah.
And what do you think about this, Stijn?
I'd like to add some points. So I think also it's kind of a mindset thing also. So I read somewhere the phrase of it's not an IT only thing. So it's every employee should be aware of potential risk, and that starts with easy things like nowadays not only a strong password is enough, but you should at least have like multi-factor authentication, for example. And of course, like you said, you need top-notch systems. The security of your software need to be according to the best practices. I think there is always like a balance between risk and budget, because like our companies don't have like unlimited budget, so you have to make choices. At defense departments, they have perhaps much more budget, but we don't have. So it's always like a trade-off. And also, I think we have to have the mindset also, if it happens, are we prepared? Are we prepared to react upon it? So that means having like a plan in place, communicating with your customers to see whether they are impacted or not. That's one thing, and the coordination, communication part, but also like technically being able to get up and running very fast again to limit the timeout.
And companies that would want to completely avoid all risks by kind of making sure for the core processes there is no connection with the internet. Would that be a possibility?
I think so. Technically, it's a possibility. Anna already mentioned like doing as much as possible locally. From a technical point of view, as a software provider company, it's more of a challenge because you have to maintain all those locally installations.
But I would think that sometimes it's really impossible. Suppose you have a core process, but you want to take into account very high or extremely negative electricity prices. Those prices, they do not come from any system within the company. They will come from an external system.
Then you need it.
Yes.
But of course, you have like those security mechanisms that are quite well proven, that only data can go in and no data out, for example. So if you really want to have external data, you can't go without, and you can't stay isolated purely locally. So you're right. You need.
We have ways indeed of isolating a gateway and making sure the data can pass in a like very safe way. On the other hand, I also want to add, like your company, my company, we're all working for very large companies. If you want to, if they hire you, you have to prove to them that you're following these standards and their ISO 27000 and so on. What I have seen is that in many cases, the infrastructure that we have built in order as at least to pass these criteria is in many cases a lot safer than the infrastructure of the customer himself. So it's something that we notice, not in all cases, but it's like if you're talking about awareness, I think it's really a challenge for us to also be future-proof on data, on security, but it's still also a challenge for industry because not all plants are equally secure. The data is not always stored or kept in a very secure way.
And that's the story of a chain is only as strong as the weakest link. As the weakest link, indeed. So, and I think also often it's again a a human thing. Some negligence of an employee not knowing that this could be a security thing. I just want to say that it's not always the IT system aan zich. It could also be like a human mistake.
Yeah. Via a wrong email or password that is hacked. Yeah, those kind of stuff. All right. Then I think we're going towards the end of this podcast. So I would like to ask you your final comment on energy management systems and artificial intelligence, and what do you see? What do you think are the future trends? Stijn?
Yeah, I always have like a mixed feeling about artificial intelligence. At first, I was like, okay, I keep the boat away.
Okay.
But now I'm more like, okay, it's coming. Let's use it. And I even start enjoying it because of it takes away like a lot of tasks that I personally am not enthusiastic about, like the boring stuff, like I said, reading, writing stuff. In IT, it's not been there, done that. So I can focus more on creativity. So that's what I personally feel about AI and the evolution.
All right.
To the industrial companies or companies in general who haven't started looking into like doing something more than just the Excel where you write down your meter data every month, just inform yourself, get started with the concept of the energy management, digital solutions. Define where is your biggest risk. Is it in your contract? Is it in the lack of flexibility? Is it in maybe you're consuming way too much? And start gathering data. It's like the first step. And when it comes to AI, I think there's a lot of... I would say we use machine learning. We've been using machine learning techniques for 10 years. Suddenly, many companies, this is AI. It's not. So, but I do think it's important that you start using systems that are AI enablers or AI able in the future. Doesn't necessarily mean you have to do something with it today, but you will certainly use it in the future. So on the short term, get started with it. Make sure you do future-proof things, and it will. I'm pretty sure in all of the cases where companies start with it, they find opportunities, they create savings, they create predictability, and so on. So I'm just a big advocate of getting started, start to understand it.
Yeah. Okay.
Yeah, the insights come from the action most often.
Yeah, it's in many cases it's such a black box. Everything that's happening. But on the other hand, and it remained quite predictable in the past. So there was no necessity to dig deeper into details. While now, when we just say to a company, your invoice will be higher this year with 25% if you continue just repeating what you've been doing in the past. It's such a big surprise. But this is this will be the future. So, so I would, if you just start, it will immediately bring you insights. It will immediately make clear where the path is that you should take.
Okay. My takeaway is that to go from where we are today to an integrated system with a lot of capabilities to predict stuff, to optimize stuff, it's a long way to go. but that is a very important way to go to remain competitive.
Absolutely.
All right. So, okay, thank you. I think we're now near the end of the podcast. So thank you both for being here, Stijn and Anne.
Sure.
You're welcome.
Yeah. And let's now go to our work and get EMS rolling.